Welcome everybody, and thank you for joining our webinar. Today we'll be talking about return path analysis and some strategies for that. Before we get started, I just wanted to cover how you can ask questions and how they'll be answered. So you should see on your screen something that looks like this. It may already be expanded. You can open that or close that by using that little arrow right there and just type your question in the box, and we'll be happy to address those at the end. So you can ask questions at any time. Anytime that a question comes up, just feel free to type that in. At the end, we'll take a look at those, and Scott and I will answer those questions. And if we don't happen to get to your questions, by the time the webinar is over, we'll certainly respond. We'll still have a record of that, and we'll respond to you later. So just let me introduce myself and Scott. I'm Rick Uzzi, Vice President of Marketing here at ZCorum, and I'm joined by Scott Helms. Scott is our VP of Technology. He's responsible for everything technical here, which would be our own networks, the people that keep those up and running, the networks of our customers that we work with, where we help them with their CMTSs and other broadband equipment and networks, and also our development team and the different diagnostics products that we have are also under Scott. So Scott, welcome.
Good afternoon, Rick. Thanks.
So today, let's get started with a bang, or maybe that's a foom. So what we're looking at here is something that kind of represents the funneling effect that a lot of operators are familiar with. Why don't you explain this?
Yeah. So what this graphic is showing that what happens with ingress noise is that it gets funneled up to the head end into our CMTS, and that really causes us a lot of problems. I think everybody's familiar with this concept. You know, it's kind of the opposite of problems in the downstream, where you kind of have to go out to a lot of different points to understand how the downstream is being impacted. All of the signal and all of the noise gets funneled back to the head end, so it all gets concentrated in one location.
So the good news is you don't have to go anywhere to see it, but the bad news is it's all together.
Yeah, I mean this is what creates our noise floor.
Right. So here's another way of looking at this. So while it's not bangs and clangs, it's a different kind of noise, right?
Yeah, exactly. I mean, what you're looking at is kind of the layout for a single node, and how all of this RF energy gets transmitted back to the CMTS.
Mm-hmm. And while it may be little small sources of noise, as this goes back to the CMTS, it's accumulating. Is that right?
Yeah, I mean, what happens is again, it's the funnel, because we have all of this energy being collected in the plant and heading upstream. We block it from going back downstream by using directional couplers in our taps and in other parts of our plant. And so what happens is that noise can go upstream, but it can't really go back downstream in the upstream part of the frequencies. So we have all of this energy going up towards the CMTS, and it concentrates over that distance.
Mm-hmm. And you know, it seems as I look at this, you know, it seems to me like the closer you were to the CMTS, the worse it is. But these guys that are really out on the edges are just as affected, right?
Yeah, I mean, at the end of the day, it doesn't matter where you're located. If you're in a node that has noise, which at the end of the day we all do.
So as we're looking at this, we're seeing basically the network, as you said, it's a node, and you've got all of the energy funneling back to the CMTS. So.
Yeah, that's right. So now everybody can kind of see what we've been talking about. You know, we have a normal kind of layout, and we show basically little places where ingress is getting into the plant, and all of this ends up flowing up to the CMTS.
Okay. So let's talk a little bit about where this noise is going to be coming from. So anywhere, I guess, where you've got a breach?
Yeah, I mean, and again, none of this information is going to be unfamiliar to people who've worked in cable before, because these are all problems that we've dealt with, and in some cases kind of shook our heads and not dealt with. But any place you have damage to the physical cable plant is going to allow signal both to come into the plant as well as to leak out of the plant. So ingress and egress are kind of go hand in hand. They're two sides of the same coin. And in almost all cases where you have a source of ingress noise, you also have egress noise, and vice versa. Mm-hmm. So this is one of the reasons why we focus a lot on proactive network maintenance, because what that tells us is it helps identify impedance mismatches which are often caused by these exact same problems. Mm-hmm. So while P&M doesn't directly address ingress noise or egress noise, in a lot of cases, the problems that it identifies are sources of that kind of noise.
Right. So you can see through a P&M tool that you maybe have a squirrel chew somewhere or a loose connector, and then that's going to be a source of ingress as well.
Absolutely, especially in the home.
Mm-hmm. Okay. And this is an interesting fact that anywhere from 75 to 95% of this is either at the home or the drop. And I think the majority of that, maybe 70% out of that, is actually in the premise, right?
Yeah, I'd be one of the people that would say it's closer to 95 than 75%, and almost all of that is definitely inside the home. That's where we have the most vulnerable cabling. In some cases, it's not even cabling that we put in as the operator; it's cabling that the builder put in. It's also cabling that the consumer themselves has messed with and possibly installed part of and added splitters and amplifiers and all kinds of things. And even if they haven't physically added things, they move TVs around and they move furniture around. And so especially just loose connectors get banged up, they get pulled and tugged on, and that's why we have so many sources of potential ingress. But we also have lots of noisy things in the home to take advantage of those holes.
And a lot of people don't realize that they turn that cable a few times. It feels like it's tight, and it's tight enough, right?
Right.
Yeah. So they don't think about having to be really tight to keep noise out. And this is something interesting that operators might not think about is you've got to properly terminate an X subscriber. If you disconnect somebody and then that's not properly terminated, that can be a source of noise.
Yeah, absolutely. I mean, the cable plant, if you don't actually disconnect that drop from the tap or make sure that it's completely trapped out, you're still completely vulnerable to all of that noise that's coming in. And we've tried to do a lot of things in the cable business over the years to mitigate ingress noise. One of those things, trapping all the upstream frequencies, except for our customers who use our data services, which is now such a large percentage that we can't really do that anymore. And in some cases, we've run into pain because we tried to do the right thing by trapping the frequencies that weren't in use. And then we went back and under DOCSIS 3, we started adding new upstream frequencies, and now we got to go out and change all of our traps out. So, it's one of those things that we've struggled with throughout the history of cable operations.
Mm-hmm. And just because you've got this place where noise can get in, that doesn't necessarily mean that you're going to have noise in your plant.
Absolutely correct. There's got to be a source as well.
Mm-hmm. So a good analogy is what? A roof?
Yeah, I mean, if you think about it, if I've got a hole in my roof, that hole's there whether it's raining or not, but I'm only going to get wet if it's actually raining.
Yeah, so you may not ever know you have a problem until it actually rains.
Exactly.
Yeah, okay. All right, so, but there are sources of noise out there. They may not always be around, but what are some of these and how are they impacting the cable plant?
Yeah, I mean, a lot of these, again, are going to be familiar to most of our audience because these are all problems that I think we commonly have dealt with in the past. There is a lot of sources of RF noise in the environment, and some of these are intentional emitters and some of them are unintentional emitters as the FCC thinks about them. But all of them are going to produce RF energy that can leak into our plant. LTE is one of those really special kinds of problems in that not only are there large broadcast towers that are going to potentially impact our outside plant, we have more and more handsets and devices that are using the LTE bands inside the consumer's home, and that really means that we have a really good chance to get interfered with by the LTE bands, both from the outside plant as well as the inside home environment.
And do these devices or these interference sources, let's say they're not on this list, but if they're not at the same frequency, does that matter or not?
Well, I mean, it needs to be the same frequency once it's on the cable plant, one of the bands that we use either in the upstream or the downstream. But it doesn't necessarily have to be the same frequency as it's emitted. It's very possible for RF frequency to shift so that a frequency that's not in use on the cable plant that's in the air can get shifted by either a reflector or another source of interference. so that it is something that interferes with one of the bands that we use.
Okay, and once there's noise in the plant, it's going to have an impact on the operator's service. So we're seeing here basically the triple play impact, right? So video-wise, is that one of the first things that's going to be noticed, or is it?
Yeah, well, it depends on what part of the spectrum we're getting, interference on. So if it's ingress that we're worried about that's going to the head end, what we're really thinking about is our upstream bands. Those will be things that would, keep our cable modems from being able to effectively communicate with the CMTS, which would cause your slow internet and potentially poor quality voice calls, but also could keep a set-top box from being able to communicate to the head end and keep a customer from being able to do something like ordering a pay-per-view movie. Mm-hmm. And then we have ingresses, like we've been talking about LTE a fair amount. That's going to primarily be a downstream interferer, and that's going to give you that kind of tiled digital video example that you're showing on the screen and play a lot of havoc with our analog video.
Mm-hmm. And does this is this something that you see a gradual degradation of the service, or does it happen all at once?
It really depends on the scenario. You can actually have both kinds of situations. It's certainly very possible where you can over time find that your noise floor keeps creeping up, and you kind of look at it and go, well, it's only going up a quarter of a dBm a month, but you let that go for a couple of years, and then suddenly you really don't have a lot of margin between your cable signal, your DOCSIS signaling, and the noise floor, and now your SNRs are bad. Mm-hmm. You can also have that fall off the cliff kind of scenario. I worked with an operator in coastal Georgia, where several years ago they had the G8 summit, and they had a situation where they really didn't see an ingress problem until the G8 summit was getting cranked up, and then suddenly there were a lot more sources of both ground and air-based radar, and this caused them really significant problems for a few weeks, much more than they could actually go fix, because there was suddenly many more powerful sources of RF energy in the area that weren't normally there, mm-hmm. and all of the ingress holes that they didn't know about were suddenly being used by this RF energy.
Right. So we can talk a little bit about how to find these ingress points. Now, of course, the first step is to know you've got a problem, and we're going to cover that in a minute with some of the tools that people will use. But before we get there, let's talk about, once you know you have a problem, what do you do about it?
Yeah. So finding ingress, because we have the funneling effect that we talked about at the beginning, can be really tough to try and locate. And traditionally, what we've done is go out into the plant and basically disconnect a leg off of the node at a time and see what the impact of that is at the head end. Mm-hmm. Now, here's your bullet point here is, it can be a little difficult to do that as a solo job, right. Because obviously if you have one guy out in the field, you need somebody else to look at this in the head end. Mm-hmm. And some operators have actually taken the step of putting a channel onto their downstream and pointing a camera at their analyzer, so you could actually see the spectrum analyzer remotely.
Okay.
But then you need a TV set out in your truck, which
fix.
Yeah, Mm-hmm. So there have been some creative things that people have done, and there are definitely some hardware and software solutions to do that. But in a lot of cases, it's just that it's a couple of guys on the phone or on the radio talking about what they see on the meter, and the other guy disconnecting one leg at a time.
One at a time until they see if it goes away, and then kind of like rain, there's not always a downpour. Noise can be bursty, right?
Yeah, this is the most frustrating thing, right? You realize you've got a problem, and you have to arrange to take down parts of the plant so that you can do a divide and conquer, and you also have to schedule around everybody's time so you can get it actually done. And by the time you go out there and start looking, that noise source may or may not be there. And this is one of the most frustrating things that I think most people in cable operations have gone through.
Mm-hmm. So some of the tools that we have, one would be, as we've talked about, kind of the spectrum analyzer in the head end, and there's a couple of options there. So tell us a little bit about these vector analyzers.
Yeah, so VSA is actually a really nice tool. It's one of the things that an operator may or may not have. They're pretty expensive. You can sometimes get them on the used market, but they also tend to be a little complicated to use, much more than a regular spectrum analyzer. A VSA is something that has the brains to actually decode the DOCSIS signaling, and this is important compared to just a regular spectrum analyzer, because if I'm looking at my cable signaling with a regular spectrum analyzer, I can't really tell the difference between what is the cable modem talking to me in the head end versus what is a source of noise that's in that exact same part of the frequency. A VSA can see those two things.
Okay. And then there's the lower cost analyzers that probably a lot of operators are going to have.
Yeah, I mean, everybody's going to have meters and spectrum analyzers that they can use to look at the signal. But again, I mean, you're limited, and the nicer the meter, generally the better it can do. But you really run into some problems trying to distinguish between, okay, is this part of my cable modems talking to me, or is this something else that's on the channel?
And again, this is going to be where you got your buddy in the field probably.
Yeah, exactly.
Stuff, yeah. And then you've got return path monitoring systems. These are nice. These are pretty powerful. There's a lot you can do with them, but there's some downsides to these, right?
Yeah, I mean, and I won't go into names because I think everybody probably is familiar with the names that are out there. But these really sound great, and if you diligently use them the way that they're designed and keep up with additions to your CMTS, you always add ports onto the return path monitoring tool. They're actually very effective. My complaint about them has never been that they work or they don't work, because they absolutely do. The problem is it's space, it's cost, it's training. I see most people start with really good intentions and plan on using it, but after a few years, they haven't kept up. As they increase port counts on their CMTSs, they haven't done the same thing on their return path monitoring tool, and so it takes somebody going into the head end and moving cables around, which means you don't catch anything historically. And the other thing is, you may or may not, depending on the model, be able to see noise under the cable modem's transmission. Some of them you can, some of them you can't. But it's tough to make them work economically has been the problem.
Right, and I guess you're splitting the signal, so you're not seeing exactly.
Yeah, I mean, you're sampling part of the signal, and the sensitivity on those chips as compared to what's in the CMTS is going to be close, but it's not exactly the same. And that's one of the drawbacks of using the systems, is it's seeing a problem, and if it's a big problem, it's going to be right. But there's some things where it's something may be more of a problem to the CMTS than the return path monitoring tool thinks it is.
And again, because of the cost, a lot of times they don't monitor all of their channels, right? So that brings us to really the topic today, which is how you can use your CMTS as a spectrum analyzer. So in other words, if they've got a CMTS, they really have the equipment they need if they've got one that supports this, right?
Yeah, I mean, that's the key idea, is you really have to try and make upstream monitoring as painless as possible to make it really widespread.
So no hardware, no switches, nothing they need in the head end. Basically, it's software based and available 24/7.
Yeah, that's the whole idea, is to be able to use the CMTS this way, so that we don't have to add cost as we add ports. I mean, honestly, buying more qualms from our CMTS vendors is expensive enough when you have to go to purchasing and say, not only do I need to buy a new 3G60 or whatever blade, I also need to go buy another blade and a set of RF switches for my upstream monitoring tool. And that's really why people fall behind on it.
Okay. Let's see if we can take a look at upstream analyzer right now. So I'm going to switch over to that. So Scott, show us what we've got here. This looks like a standard spectrum analyzer signal.
Yeah, so what we're seeing is is basically a specific cable modem. We're looking at our entire upstream frequencies. You can see down here, 12 to 16 megahertz. We have all of the CB band noise. Mm-hmm. And you can see we actually have some cable modem transmissions on another frequency because of how we've got our return path, or excuse me, our combining plant set up. So this port is actually seeing both the modem that we're looking at and modems on a nearby frequency. Mm-hmm. So you can see here that we're actually filtering on a specific cable modem. This is our guy right here. We chose somebody beforehand who's pretty bursty and talking a lot. But one of the things that's really nice is we have the ability to enable this flag here, the ingress under the carrier. And what this lets us do is, because the CMTS knows what is and what is not one of its cable modems on this specific upstream, you can see we've got the upstream selected, we can actually understand what is and is not the cable modem's transmission and how that relates to our overall signal. Now it's showing all of this over here as being ingress. That's because this isn't traffic that's going to this port, mm-hmm. but this is what we care about here. And you can see that our ingress is not very high in comparison to our signal peak. Mm-hmm. So in this case, our carrier to noise ratio is quite good. Mm-hmm. And we have a lot of the normal kinds of features that you would expect to see on the spectrum analyzer. So I can, for example, set up vertical references so I can see exactly what the delta between two parts of the signal is, what the frequency ranges are, and I can turn those on and off. As I said, we've got our ingress detection running right now, but we can also do things like max hold. Mm-hmm. Again, this is a normal kind of function of a spectrum analyzer. And this really lets us see what our modem is doing and what our environment looks like over time.
And the reason this can see ingress under the cable modem, I guess, is because the CMTS knows when it's communicating. Is that right?
Yeah. So if you think about it like this, and I just changed the resolution bandwidth on here so we can get a little more granular. But if you think about what happens for the cable modem burst, is the CMTS is always telling the modem specifically, you can talk now, you have this time slice, and so the CMTS knows explicitly what is and is not a cable modem transmission.
Mm-hmm. Okay. And people, I'm assuming one of the questions we're going to get is what CMTSs does this work with currently?
Right. So yeah, we can go ahead and answer that one.
We'll answer that ahead of time.
Excuse me. So this is running on the Cisco CMTS. This is a 10K specifically. We're working right now to get this working on the RSC4 and the E6000. And we should have that in the next month or so. But right now it works on all of the current Cisco gear.
Mm-hmm. And so the ARIS is on its way. Mm-hmm. And this is something, one of the advantages of this, so again, this is a software-based tool, so there's nothing in the head end that's needed. It's basically software as a service where the person can view spectrum wherever they happen to be. So any number of people that need access to the tool can get it, and they can view it from a PC, a tablet, even a smartphone, right?
Yeah, correct. So I don't necessarily have to have a partner if I'm going out in the field so I can do my divide and conquer work. I can pull this up on my tablet or my laptop and just have it running as I'm actually doing the work out in the field.
Fantastic. Okay. I'm going to go ahead and go back to take some questions. Let's see if we have any here. So again, you can just ask a question. There is a arrow that you can expand. I don't think that was showing earlier when we were talking about that. There's an arrow that you can expand and just type a question in the box there. And let's see if we have any. Expand that out. Okay, so question on cost. How much does this cost? That's always a question somebody wants to know. So basically, because there's no hardware or cabling or anything like this, this is a much more affordable solution than other kinds of products. So it's priced per port. It's only, really it works out to only a few pennies per day per port for this product. So it's something that allows them to have that upstream analysis in their plant we'll be happy. Just go ahead and if you have a question on price, we'll get back to you. Just send us an email. You'll see here we've got info@ZCorum that you can send questions to, or just ask a question on here. A question about PNM. So again, we were talking about PNM and the ability to see impairments, Scott. So somebody's asking about the price of that. That's also very affordable. Just send us your questions on that. We'll get to you on the PNM questions. So,
sure.
What else have we got here?
Yeah, it looks like we have a couple of people who asked how much processing power does this take from the CMTS, which is a really good question. The answer to that is what we've seen in live deployments is it's actually quite mild. It's creating about a 4 to 5 kilobit per second stream of data. It's actually not stressful in the CTS. We're talking in order of less than 1% on the CPU so far, at least is what we've seen.
Okay. And what about the modems? Somebody's asking a question of the type of modem that you need. Is there any question there, or any particular type of modem? DOCSIS 1, 2, 3?
Yeah. So it doesn't matter the type of modem. Because the CMTS is actually collecting the information, so that's not a problem, that doesn't matter in terms of DOCSIS 3 versus DOCSIS earlier versions of DOCSIS 3.2 megahertz wide upstream versus the 6.4. All of those are fine. We had a question about is it possible to see the entire upstream? Yeah, we just don't select the cable modem. And you'll see the entire upstream. And then there's a question about the CASA. We are actually trying to get the CASA working. We're originally working with them on one of their older platforms, and that one's discontinued. So there's a version and a model requirement, but yeah, this should work on the CASA sometime in the next few months.
Okay. From Ben, is the software installed on the CMTS?
Okay, so this is actually leveraging the functionality that's already on the CMTS. So there's no software that has to be installed there. So the CMTS itself has this built in. All 3.1 CMTSs actually have this as part of a standard, as part of the Cable Labs 3.1 spec. So all of the 3.1 CMTSs, of course, none of us have those yet. So all of the stuff that we're doing right now is based on the vendor's specific way of doing spectrum analyzing, and it's not really standardized until DOCSIS 3.1. But like I said, it is working today on 2.0 and 3.0 Cisco CMTSs. We're in beta right now with the Aris C4. And hopefully later in the next few months we'll be able to get the CASAs.
Mm-hmm. Okay, and then a similar question as before is where does the application reside? So basically it's hosted here, so
Yep.
There's nothing that is hosted at the provider's location, and we just pull the data from the CMTS.
Yeah, most of the time. We actually do host pre-equalization analyzer and upstream analyzer locally, but it's usually something where we want the operator to have their own virtual infrastructure in place to handle server failover and dynamic scaling. So if you've got a good VMware set up and a good server and storage infrastructure there, we should be able to deploy locally in some cases.
Okay. Frank's asking
about the E6000.
E6000.
Yeah, the E6000 and the C4 use the same MIBs. So as soon as the C4 is done with beta, it will work in the 6000 as well.
All right. Bill is asking, can this program and TrueVision communicate with one another? Is there? Let's see, that's a different question. So can TrueVision and this communicate together?
Not today. That is part of the development plan. So the goal for this is to kind of merge all of these pieces into one dashboard, but today they're separate.
And this is another good question on future. Is there a long-term recording monitoring component? That would be nice. So over time to see what's going on. Is that in the plan?
Yeah, absolutely. I mean, what we're planning on doing is getting a long-term piece put in place so that we can automatically detect an alarm on problems that we see on the upstreams.
Great. Okay. I see a few more questions about price. Someone's asking, can I get a price quote? And absolutely, we'll have your information from this webinar. We'll be able to send you a price quote. Having a hard time. Let me see if I can expand these questions out. It's hard to read in the way it is now. There's another question about historical data, so we covered that. Let's see, what does this question say? What is the benefit of using your program rather than someone else's?
So probably the biggest benefit is there's not really a lot of availability of this. The ones that I'm aware of are all from the vendors specifically. So, for example, Eris sells a module, and Cisco, if you can find the right person, actually has a module that they'll sell, a piece of software they'll sell. The challenge there is neither one of them are really core to what Cisco or Eris do, and frankly, it's more expensive buying it from either one of them. The other challenge is, of course, Cisco's tool only works with Cisco CMTSs, and Eris's tool only works with their CMTSs. Mm-hmm. And so if you've got a mixed environment, you end up buying software twice.
Right. Okay. And let's see, a question about, are there other features? We'll get back with that person on features. We can do live demos of these. We'd be happy to do that. A live demo of the product, again, specifically for somebody. Also, you'll see on the screen that you can get a free trial of this, again, because there's really no setup for the operator. I mean, basically, maybe you can cover really quick, Scott, if somebody wants to try this out, what we do here and what they have to do.
Yeah, it's really just a matter of getting communication to the CMTS, which means SNMP. We do need the read and the write strings. We use the read strings to gather some information about the interfaces and the modems. Mm-hmm. And then we have to have the write string to be able to actually enable the spectrum capture on the CMTS.
Okay. And there's a question about, is there a phone app for the iPhone and for Android? And there's not, but you really don't need one in this case. At least I know I've looked at it on my phone through my web browser.
Yeah, this is a mobile enabled web page. We are looking at doing these things as native apps, just the way that we've done with TechVision. Yeah. But for right now, it's a mobile enabled web page, mm-hmm. and it actually does work pretty well. Yeah. Especially the spectrum analyzer piece is pretty easy to use.
Yeah. Another person asking for a price quote. We'll be happy to do that. Okay. Let me see. Just another minute. So again, if I see another question here, I'll take it in just a minute now. So again, you can request a free trial. Just go to upstreamanalyzer.com and click the button for a free trial, and we'll get that set up for you. If you have any other questions that come up after we close the webinar, you'll see right there you can send that to info@ZCorum, or just give us a call at 800-909-9441. We're looking to see if we've got any other questions. I think that's it, Scott. Any other comments?
No, just really excited about the feedback that we're getting today.
Mm-hmm. Yeah, these are some great questions, and again, it's something that it's kind of the future, really. So you can get away from some of the equipment and cabling and other things that you need, and I think where everything seems to be going is that you can access this information wherever you happen to be, and that's really the big thing, whether it's downstream spectrum out in the field on a smartphone or upstream, same thing. So again, everybody, we appreciate your time joining us today. Thanks so much, and if you have any questions, just let us know, and that's the end of the webinar. We appreciate your attendance. Thanks a lot. Bye-bye.